Okay, homework question number 4 of lesson 7. If the side lengths of a triangle are different prime numbers, we call it prime triangle. Is that possible? A prime triangle is a right angle triangle. So we learned the Pythagorean theorem. It's like if you got right angle triangle, the two shortest side, if you square them and add them together, that equals to the longest side. You square that, right? So we can get this formula here. A squared plus B squared equals to C squared. And then you're going to choose the prime number for the length of the three sides. And let's see is that possible, right? So for the prime numbers, the smallest prime number will be 2, which is only even prime number. And after that, you got 3, you got 5, you got 7, and then 11, and so on and so forth. And so let's do the odd-even analysis for the question. For example, if A and B are odd numbers, okay, are odd prime numbers, then you'll find that odd number squared is also odd number. For example, 3 squared, you got 9, is also odd number, right? So if A and B are both odd prime numbers, and you square them, you're going to get 2 odd numbers as well. And then you add 2 odd numbers. That means C squared equals to an even number, right? C squared is an even number. Right? If C squared is an even number, that means C must be 2. But that is not possible since C is the longest side, right? C cannot be 2 because 2 is the shortest, or 2 is the smallest prime number that you can have. So C cannot be 2. That's why this is wrong. So it means A and B cannot be odd numbers at the same time. So that's the first scenario. Means it doesn't work. And now we can try that if A and B, one of them is even, because you have only one even number, right? And another is odd. All right, another is odd. So actually there's no difference. You can set A as 2 or B as 2. So let's say A equals to 2. If A is 2, then A squared equals to 4. So what does that mean? That means 4 plus B squared equals to C squared, right? And B and C will both be prime numbers. And now we can try some adjacent prime numbers after 2. For example, if you do C equals to 5 and B equals to 3, you'll find that 5 squared minus 3 squared equals to 16, right? And then you see that much larger than 4. It's not possible. And then we can try the next 2 prime numbers. If you try 7 squared minus 5 squared, you'll find that equals to 49 minus 25, you got 24. You find that the difference of these adjacent odd prime numbers is getting bigger and bigger if you choose a number larger in this sequence. So that means it's not possible you got a difference equals to 4, right? So based on these 2 different scenarios, you can see that it is not possible to get such prime triangle in a right angle triangle. So we're going to choose B for this question.